Okay, so the first part of this lecture is to discuss the midterm. I will only talk about question 2, which is the Hadamard test. So the first question is to ask you to show how the wave function evolve along this circuit, right? So I already told you that this is the MSB on the top, and this is the LSB, right? So naturally at the beginning, then at this stage, if I call this A, right? This is B, this is C, and this is D, right? So at A, it should be straightforward. It is just 0 psi, right? You can write it in any way you want. If you write this, it is also okay. That's what I wrote. Now here psi, I did not say that whether it's 1 bit or 2 bit. Indeed, it has slash here, means this is a bus. It can be n runs from 1 to any number, right? So it can be any number of qubits. Let's assume it is n. If you assume it is 1, I think I gave you full score also, okay? So what happened at B? Right, let me just call this A. How about this? The final result is A. That will be easier. The point is we need to apply the operator, right? So what is the operator that apply to it? Right, you apply the Hadamard gate to the most significant bit, and then you do a tensor product on the identity gates, because on the least significant bits we did not apply anything, right? So as a result, it is I, but since I claim that it is n qubits, so I will say it's a tensor product of ni, right? There are ni there, right? So this is just a notation, and we apply this to A, okay? But of course, what is A? A is, if I remove it, it becomes the 0 and psi, right? And again, we know that we can apply the operator to individual subspace and then do the tensor product again, right? So you can see that H only apply to 0 and identity only apply to psi. And so this is easy. What is H0, right? It becomes the plus. And then nothing changed, right? So this is B. Of course, if you want to express in 0, 1 basis, it becomes 1 over square root 2. 0 plus 1, right? And then tensor product with psi, right? So if you further write this out, it becomes 1 over square root 2, 0 psi plus 1 psi, right? Basically, what it is saying here, 1 psi means 1 tensor product psi. Okay, so this is B, right? I say something wrong. It is, yeah, here is something I need to change. This is D. Okay, so this is B, right? This is equal, I can call it psi B, right? So for C, what happened? We apply a control U gate to it. So basically, this is a control U applied to B, right? That is what happened here. Now, it's a little bit complicated. We need to look at this. I still keep control U, but I spell out the B, which is square root 2, 0. And now let me, I'll still write in this way. I just copy the results from here to here, right? Now, we know it is linear, the whole quantum mechanics, right? So this one I can further write as 1 over square root 2 control U on 0 psi plus control U on 1 psi. Okay, and then now we can apply this. What is the definition of control operator? It means if the controlling qubit is 0, then we apply the operator to the target qubit. If the control no, we don't apply the operator to the target qubit. If the control qubit is 1, we apply the operator to the target qubit, right? So just based on this definition, you know, right, the way this is equals to 0 psi, because the control qubit is 0 in this case. So I don't apply anything, I just apply identity to psi. So nothing happened, right? And maybe because actually I want to make it write it in this way, so it will be easier to continue, right? Again, 0 psi is just 0 tensor product psi, right? But when now the control control qubit is 1, then I need to apply U to psi, right? So control qubit is not changed. I keep it as 1, right? But now I am going to apply U to psi, right? As I say, you keep the psi, keep the U. You don't touch it because you don't know what is U. It can be any gate, okay? And this is the result for the C. Okay, let me just double check, make sure that I did not make any mistake here. Yeah. Okay. Okay, now then let's go to the last part, which is D. What happened to D? In D, we actually so here I call it C. I want to call this one C instead of psi C, just to be consistent. It doesn't matter. So now, what is the gates that apply at the last stage? It's the same as B. Again, it's the Hadamard gate tensor product of the identity gate, and I operate it on C, right? So let's see what is that. Now C is pretty long, right? So I'm going to apply this whole thing to here, but through distribution law, right? So this, I will take out 1 over square root 2, which is okay. Now for the first term, when I apply h to 0, what do I get? I get plus, right? And then again, apply identity gate to psi, so it is psi. So now I skip the tensor product symbol, okay? It's the same, right? And then now I apply h to 1. What happened? It becomes negative. Again, I skip the tensor product, so the next one is psi, is U psi, right? This is a state. Operator times a vector, matrix times a vector is still a vector, right? So this is still a state, right? So this represents a superposition. This is basically the results, but not enough. I need to express it into the 0, 1 basis to make this so that we can continue. Now let's look at this. This is 1 over square root 2. And then what is plus is 1 over square root 2, 0 plus 1. Yeah, this is the plus in the 0, 1 basis and times psi, right? Another qubit. And similarly, I got 1 over square root 2 and then 0 minus 1, okay? And then this apply to U, apply to psi, okay? So I'm running out of space, but I still want to put it on the same slide to make so that you can see that easily. So I continue here, okay? So 1 over square root 2 times 1 over square root 2 give me 1 over 2. So I just take this out. I'm going to collect the terms. I'm going to collect the terms for 0 and 1 because later I'm going to do a measurement on the most significant bit. So I want to collect them, okay? So I collect them, then it becomes, let's look at this. I have 0 times psi and 0 times U psi, right? And I add them together. So I have a 0 times the whole thing, psi plus U psi. Is that okay? And then I continue to collect the term. I have 1 times psi minus 1 times U psi, right? So this is 1 times psi minus U psi. Okay, so this is the result of the D. Okay, so eventually we will get this part. Okay, let me check to make sure that I did it right. Yeah, I should actually further simplify, okay, from here to make it nicer. So let me continue. So maybe you have the notes with yourself, right? So what I'm going to do, just factorize this psi out. Okay, so what do I get? I get D equals 1 over 2, right? And then I have 0 here. And then I'm going to factorize out the operator, right? Psi go to the right, do the right product, left product, right? So this is I plus U times psi, right? This is equal to I plus U times psi. Okay, it's just the same as what I wrote earlier. Plus 1. In the one case, it is 1 minus U times psi. Right, take a look here. Because this is 1 times this whole thing, right? And this one I can factorize the psi to the right hand, to the right side of the bracket. It becomes 1 minus U. Again, 1 minus U is the operator, right? So this is the final result. Now, if we do the measurement, what will you get? I only measure the MSB, right? Because that is what I'm doing. You get either 0 or 1, correct? So basically, the wave function is going to collapse to either 0 or 1 with this term. Okay, now, then what I'm asking you is that what is the probability of getting 0, right? So this is, I think this is part B, and now this is part C, right? In the exam, in the midterm, right? And this is part A, right? So what is the probability of getting 0, right? We're going to use the projector, and that's why I gave you the equation. If you want to know what is the probability of getting a certain state, right? You use the projection operator. For example, you want to know what's the probability of getting I state. You use the projection operator of I, which is I outer product I, right? And then you sandwich it with the states that you are interested in, right? That is the probability of getting I. Okay, so this is the equation I gave in the midterm, right? So what is the projection operator of 0? Is 0 outer product 0, right? So this Pi is P0, which is 0 outer product 0. And then you want to do a product with this D, right? With it, right? So just to be clear, this part is the projection operator to project into 0, okay? And this is D, right? So if that is the case, this is not very difficult. Now we look at the D. It's a little bit complicated, right? If I'm not going to, I would do it in this way, right? This one is nothing but just what? 0 operate on D, and you do the magnitude square, right? Because this is the definition, because this term is the complex conjugate of this term, as we learned earlier, right? Do you remember? Alpha beta equals to beta alpha star, right? So now you have these two complex conjugate times itself is just equal to the magnitude square. So all I need to find out what is 0 dot product of D. And that is easy because 0 dot product of D, I already factorized it. It's going to give me 0 when it inner product with the 1, right? So basically this will give me 1 over 2 I plus U psi square. Okay. So what I'm trying to say here is that after this, right, then it will just get rid of this first qubit, but the other qubit is still there in that case, right? Okay, so I also confused myself a little bit, but I think I'm correct. Then let me continue, right? So I will just express this back to the, because this is a state, right? So the magnitude of the state is just equal to, again, psi operates on I plus U dagger, right? Because this is the bra version of this part, correct? And then you continue to put the cat version of this part. Right? And then I have 2 1 over 2, so it becomes 1 over 4. So this is the probability I will get P equal to 0. By using the similar approach, the probability of getting 1 when I do the measurement is equals to, everything is the same, right? Except this is 1 minus u. So I will get something like this. Psi I plus, no, I, because it's 1 minus u instead of 1 plus, so you get 1 minus u dagger, 1 I minus u psi. Okay. Now, in case you got confused, let me say again, right? This one, the magnitude square of this guy, this one is a matrix multiply a vector, so it's still a vector, right? So any vector, the magnitude, right, of any vector is just equal to this. I mean, the magnitude square, right? So the bra version. So the bra version of this one, of course, is this bra side, and then you put the operator on the right, but take the Hermitian conjugate. Not Hermitian, I mean the adjoint matrix, right? The adjoint matrix. So you put the dagger to here, right? And then for 1, you also have 1 minus u. So that's why everything is the same, except it is I minus u in this case. Right, so that is the probability I will measure that. Okay. Now the last question is that I think I should write in the same on the same slide also. The last question is, if the eigenvalue of 0 is 1 and the eigenvalue of 1 is -1, what is the expectation value? Well, so the expectation value of course is equals to the probability of getting 0 times 1 plus the probability of getting 1 times -1, right? For example, you have 0.2 chance of getting 0, then you will measure 1, and then you may have 0.8 chance of getting 1, you measure -1, then you will be 0.2 times 1 plus -1 times 0.8, right? That is just the expectation value, okay? Now, but we already calculated the probability on the top, right? So to be clear, I change to another color. So this basically, I just take out this 1/4, is just equals to psi and then I plus u dagger, I plus u psi minus psi I minus u dagger times I minus u psi. Right? Why it is minus? Because the eigenvalue is -1, right? So this is the final result, the expectation results. The expectation value, if I do a lot of measurement, what is the average value I will measure? Okay, so now I should actually, maybe if I simplify this first here, will make my life easier. Let me simplify this guy. This is 1 over 4, and now you look at this. This is psi, and inside I have I times I, which is I times u, which is u, I times u dagger times I, which is u dagger, and then u dagger times u. Right? I just spell it out. Do you see that? I times I times u, u dagger times I, u dagger times u. And similarly here, I have psi, I have I times I, and then I times -u dagger times u dagger times I, and then -u dagger times -u, which is this, right? And what are we doing here? We're trying to subtract this term from this term, right? So this minus this. And obviously this becomes 1 over 4 psi. If you do subtraction, I and U dagger U will be gone. But then you will get 2U and 2U dagger, right? That is the expectation value you will get if you do the measurement. Okay, so let me continue here. I say the expectation value equals to 1/4 psi 2U plus 2U dagger per psi, right? Let me check, right? That is what we got here. And definitely I can cancel it to 1/2, no problem. And then what is this? This is psi U psi plus psi U dagger psi. Now, do you remember this? Alpha times the operator U times beta equals to beta U dagger alpha star. Okay, so now alpha equal to beta, right? So we have psi U psi equals to alpha equal to beta. So even I swap you don't see it. And I have star U dagger. Do you see that? Yeah. Okay. So as a result, this is equals to 1/2 times psi U psi plus psi U psi star, right? Because psi U psi that star, right? Or just psi U dagger psi equal to the whole thing star, right? So I can, you see this? I can just add one more star here, well, a star here, right? And this one becomes psi U dagger psi. So this equal to psi U psi star. So this is a number. This is the complex conjugate of this one, correct? Yeah. If I call this A, let me call this X, right? If this is X, this is X star, just the complex number, right? So what does it mean? When you add two complex number, what do you get? When you add two complex number together, you get the real part. You get the real part of that complex number, right? So this one gives me the real part of psi U psi. And that's why this circuit, when you do a lot of measurement, give you the expectation value of U when you input the psi to it. But it gives you the real part. And there is another circuit, it give you the imaginary part. Okay? So then you will get the expectation value of psi on U.